Welcome you all to this lecture. Here we are going to cover this difference equation in terms of formulation, solution and application. Okay, but before going on to in-depth discussion of all these things, let me tell you one important aspect of mathematics, that in mathematics there are two situations. One is continuous situation, another is discrete situation, that is discrete maths. Okay, continuous means whatever the derivative or whatever the integration so far we have studied, these are under continuous scenario. Okay, continuous scenario, so that is the part of continuous discussion. Okay, whereas if we consider the discrete maths, the discrete maths you cannot apply differential equation, whereas you need to apply difference equation in the case of discrete maths. Whatever the problem, for example stock exchange related problems, this is a real world problem. So in those cases you cannot directly apply differential equation, you have to model the problem using difference equation. So likewise, there are many situations where one can take help of difference equation and solve the physical problem. Okay, so that is the basic motivation behind this difference equation, and you should know that this is a part of discrete mathematics. Okay, so let me give you few important notation so that you can relate those things with the usual or the conventional notations. For example, derivative. Okay. Or the increment. Okay, those things you can relate with the conventional notation. And in difference equation we have few important tools in difference equation. For example, the first tool, that is known as forward operator. This delta, this is known as forward difference operator. In this lecture I am going to cover this difference equation from the very beginning, and we are going to solve few questions as well parallelly, so that you can make yourself comfortable with this topic. Okay, so that's why I would recommend that don't skip the parts. Okay, whenever I am giving few exercises, all the examples, try to solve those questions by yourself first. Okay, then take help of the solution whatever we are going to discuss. Okay, so delta, it is the forward difference operator, which states that this delta, the definition of delta means delta of fx, if you are applying, so f of x plus h minus f of x, this is the definition. Sometimes we write like this, delta of yx, if I write, that is y of x plus 1 minus yx. Okay, so delta yx. So as per this notation, if you write delta y0, that is y1 minus y0, delta y1, that is y2 minus y1, so on delta yn, that is yn plus 1 minus yn. Forward difference operator. Okay, forward difference operator, this is the first order forward difference operator. Now if I apply delta square y0, delta square y0 means delta of delta y0. See the process, delta of y0 means y1 minus y0. So delta of y1 minus delta of y0. Delta, it is satisfying linearity property. Okay, so you can write like this. So delta of y1 means y2 minus y1, and delta of y0 means y1 minus y0. So you can write like this, y2 minus 2 y1 plus y0. Okay, likewise you can find delta cube y0 as well. Okay, this is second order forward difference. Okay, so likewise you can find, so it has a generalized formula, that is delta n yr, that is given by yn plus r minus nc1 yn plus r minus 1 plus nc2 yn plus r minus 2, so on it will proceed, plus minus 1 power r by r. This is the formula, generalized formula. You can Remember this formula, and this is the technique. Whenever it is required, you can take help of this forward difference operator. This is first tool. Okay. Second tool, it is the shift operator. Shift operator, that is E. It is known as shift operator. Shift operator. So shift operator says that if you apply y, if you apply on yx, okay, so it becomes y x plus h. Okay, that is the shift operator. Shift operator, that is, if you like fx, if you are considering fx and apply e on fx, so it becomes f of x plus h. Okay, this is shift operator. So this is the first order shift operator. So if you are going to apply e square fx, just like our previous discussion, e of fx. So e of fx means f of x plus h. So that is nothing but f of x plus 2h. Okay, so likewise you can have e power n fx. The formula, this is given by f of x plus nh. Okay, this formula you can remember. Okay, en fx, that is f of x plus nh, and delta power n yr, we have this formula. Okay, so now there is one relation between E and delta which is very important for our discussion. So I am moving to the next slide. So here, if I consider, suppose delta yn, it is given by yn plus 1 minus yn. Okay, yn plus 1, this is nothing but e of yn minus yn. Okay, so you can write like this, e minus 1 yn. So basically what you are having, delta of yn, that is e minus 1 yn. Now if you compare both sides, basically you are going to get delta equal with e minus 1. So this is relation between delta and e. So that is e, you can write delta plus 1. These are operator, so you can write like this, delta, it is equivalent with e minus 1 and e equivalent with delta plus 1. Okay, so these formulas can remember. Now see, whenever we are applying e inverse of fx, suppose e inverse of fx, so we know that e power n fx means f of x plus nh. Okay, x plus nh. So e inverse, that is f of x minus h. So this formula also you need to remember. All right. So these are few important notation, that is delta operator, that is the forward difference operator, then shift operator e, and just now we have this formula, that is the relation between e and delta. Let me give you the idea of difference equation. So difference equation, what is the formal definition of difference equation? See, difference equation, it is a relation between the differences of an unknown function. Okay, of an unknown function. Now see, for example, if I write yn plus 1 plus yn equal with 0. Now see, this yn plus 1 we have, and yn, this term yn plus 1 plus yn equals to 0. So in this case what we have, this is one example of difference equation. If I write suppose yn plus 2 minus yn plus 1 plus yn is equal with 5, this is another difference equation. Okay, now based on the physical problem we can have different type of difference equations. Okay, we can have linear difference equation, we can have non-linear difference equation, we can have homogeneous or non-homogeneous type of equation. Okay, so this is the formal definition of difference equation. Now see, whenever we are considering difference equation, immediately you should know that order. What is the order of difference equation? So because in our differential equation, in the beginning days, first of all we introduced differential equation, then the order of differential equation, then we considered how to construct differential equation, then we converted those equation and then we considered those equation and try to solve them using different methods. Okay, just like that we'll proceed further. Okay, so what is order? Order of difference equation. Order means here the difference between the largest and the smallest argument. Okay, that is the difference between the largest and smallest argument. Occurring in difference equation. Okay, so if you consider this first equation, so here you can see n plus 1 minus n, so 1, the order it is 1. Similarly here in this equation, if you see n plus 2 is the largest and n is the smallest, so minus n, that is 2, the second order equation. Okay, likewise one can find order of difference equation. So if I write suppose another equation, suppose y n plus 1 into yn minus 1, that is equal with 2x n minus 2. If I write suppose yn minus 2, so if I write this equation, see this is also difference equation, but what will be the order? So in this case, highest one, what is the highest? N plus 1, and the smallest one it is n minus 2. So n plus 1 minus n minus 2, so in this case 3 is the order. Okay, this is how one can find order of difference equation. Okay, now see here in terms of y I have given these equations. It is not necessary that always you will be getting in terms of y. Okay, there can be equation like this. See, delta cube yx plus delta square yx plus delta yx plus yx equals to 0. Okay, this equation you can write in terms of subscript notation. Write in subscript notation. So in that case, the formula that we are going to apply, that is delta power n yr, that previous formula. So yn plus r minus nc1 yn plus r minus 1 plus nc2 yn plus r minus 2 and so on, plus minus 1 power r yr. This formula we are going to apply. So in that case, see this equation, if we want to write in terms of this subscript notation, so this equation it can be expressed as this first part. For this first part, that is y n plus r, so what will be here? Y x plus 3 yx plus 3 minus 3c1 y n plus r minus 1 n plus r, so it is x plus r minus 1 x plus 3 minus 1, that is basically yx plus 2. So you can write like this, yx plus 2 plus 3c2 yx plus 1 minus 3c3, that is yx. This is the first part, plus for the second part, that is yx plus 2 minus 2c1 yx plus 1 plus yx plus delta yx. Okay, so that term you can write yx plus 1 minus yx plus yx. So now we just need to simplify, that is yx plus 3 minus 3c1, so 3 yx plus 2 plus 3c2, 3 yx plus 1 minus yx plus yx plus 2 minus 2 yx plus 1 plus yx plus yx plus 1, here get cancelled. So ultimately if you simplify this one, you are going to get yx plus 3 minus 2 yx plus 2. Just see this one, yx plus 2. Here we have another term, and then we have this one, and this one. These are the terms. So it would be plus 2 yx plus 1. Now this term and this term get cancelled, so we have this one. So this is the equation. Okay, this is the equation. Now see here, what is the order? See, x plus 3 minus x plus 1, highest minus lowest. So we have 2. The order is 2. Now another type of question is there, that is formation of difference equation. So now we are going to see the formation part, how to construct difference equation. So for that, first question, let me write, find difference equation whose solution is given by yn, it is a into 2 power n plus n into 3 power n minus 1. Second question, y is equal with ax square minus bx, it is yx. Third question, yx, that is a by x plus b. Fourth question, yn, that is a cos n theta plus b sin n theta. Okay, find difference equation whose solution is given by first one, second one, third one, and fourth one. Individually we need to check. Okay, so how to deal with this type of problem? Now see, for the first question, solution for the first question, yn, it is given as a into 2 power n plus n into 3 power n minus 1. Now here, how many arbitrary constants you have? See, a is the only arbitrary constant. Okay, in the case of differential equation, what we did, suppose we have second order equation, there should be 2 arbitrary constant in the solution. Okay, if the equation, the differential equation, it is of third order, there should be 3 arbitrary constant in the general solution. Likewise here, if 1 arbitrary constant means that is guaranteed that the equation will be of order 1. That is confirmed. Okay, from this given setup, that is confirmed, equation will have order 1. Okay, so if it is equation order 1, so what will be our work? See, in differential equation, if you just go back, ultimately solution given and we need to convert, or we need to get the equation back, means we need to eliminate the arbitrary constants. That was the idea. Here the same thing will happen. Okay, so we need to eliminate the arbitrary constants. So for that, first this is the given thing. Okay, as per this notation we'll write y n plus 1. So what will be that? A into 2 power n plus 1, n plus 1, 3 power n. See, we cannot perform derivative here. In difference equation we cannot apply derivative here. Instead of that we need to consider the steps. This is suppose nth step, this is the n plus 1th step. So wherever we have n, just write down n plus 1. So now from this one and this one we need to eliminate this a. So for that what can we do? See here, these two equations, suppose this is equation 1 and equation 2. So from equation 1 what you can write, yn minus n into 3 power n minus 1 by 2 power n, that can be expressed as 1. And from 2 you can write yn plus 1 minus n plus 1 3 power n by 2 power n plus 1, that is a. Okay, because this is a and this is also a, so you can simply write this left hand part equal with this left hand part. So what you have, see, so from here yn plus 1 minus n plus 1 3 power n by 2 power n plus 1, that is equal with yn minus n into 3 power n minus 1 by 2 power n. Now see, a is eliminated. So immediately what you can write, yn plus 1 minus n plus 1 3 power n, here 2yn minus 2 into n into 3 power n minus 1. This one immediately you can write. Now you can change the side, and here what you have, see, n plus 1 3 power n minus 2n 3 power n by 3, you can write like that. So n plus 1 minus 2n by 3 into 3 power n, that is going to be equal with n by 3 plus 1 into 3 power n. So ultimately what we have, see, yn plus 1 minus 2yn, it is n by 3 plus 1 3 power n. So this is our required equation. Okay, so solution given and we can write the equation like this. So basic idea is to eliminate the arbitrary constant. Okay, now next we have this one. See, we can try this question, second question. So second question it says that yx solution, it is given as ax square minus bx. Okay, so instead of n, x it is given. Okay, index it is given as x. So here you can see two arbitrary constant, a and b. These are the two arbitrary constants. So we need to eliminate these two constants. So that is guaranteed the equation will have order 2. So in that case first work will be to write yx plus 1, that is a x plus 1 square minus b x plus 1, and yx plus 2, that is a x plus 2 square b x plus 2. So we have this equation. Suppose this is equation number 1, this is equation number 2, and this is equation number 3. So from these three equations we need to eliminate a and b. This eliminate. Okay, so these two, a and b, you need to eliminate. So one way is to solve either of these three equation. Okay, that means either you take 1 or 2 or 1 or 3 or 2 or 3, you take either of these two equation. Okay, out of these three you can take 2 at a time and solve for a and b. Substitute in the third equation. Okay, whatever the remaining equation you have, just substitute there and the expression will give you the required difference equation. Okay, this is one way. So that means if we are taking 1 and 2, solve for a and b, substitute that a and b here in third equation, and ultimate form, that is the required equation. Okay, so this is one way. Another way is what? Using the determinant, concept of determinant. So in that case this determinant you need to take. See, to eliminate to eliminate a and b, what we can do, we can take help of this determinant yx plus 1 yx plus 2. Here what we have, x square, x plus 1 square, x plus 2 square. Here b, the coefficients are minus x plus 1 minus x plus 2. So as the sign of all these terms are same, so we can simply take x plus 1, x plus 2, make it equal with 0. Okay, and after that you need to solve and simplify. You will get the equation ultimately yx plus 2, you can verify it, x square plus x minus 2yx plus 1, x square plus 2x plus yx into x square plus 3x plus 2. Okay, we can verify this one. Okay, so the process is this. Clear? Likewise, if you consider the third problem, so in that case, see, third problem, it says that yx, it is a by x plus b. Again, two arbitrary constants you have, so the equation will be of order 2. So in that case, yx plus 1, you will find that is a x plus 1, b y x plus 2, it is a by x plus 2 b. Now from this setup, you need to write yx plus 1, yx plus 2, 1 by x plus 1, 1 by x plus 2, and see b, the coefficient, it is 1 1 1. So make it equal with 0 and solve. Okay, so likewise you can solve. Take another problem. Third question you can try by yourself. There also you have, or third question, let me give you the outline. That is the fourth question. So let me give you the outline. That is yn, it is a cos n theta plus b sin n theta. So again, two arbitrary constant. So yn plus 1, that is a cos n plus 1 theta plus b sin n plus 1 theta. Yn plus 2 is a cos n plus 2 theta plus b sin n plus 2 theta. Now from this setup, you need to write this matrix determinant, in fact, yn plus 2 cos n theta, cos n plus 1 theta, and cos n plus 2 theta. Here you have sin theta, sin n plus 1 theta, sin n plus 2 theta. Make it equal with 0 and simplify. Okay, likewise we will solve. Take another problem. Suppose solution, it is given by, suppose yn, it is equal with a 2 power n plus b 3 power n plus half. Suppose yn is this one, then equation. What is the equation? So here also two arbitrary constant, so we need to find those terms. Yn plus 1, that is a into 2n plus 1 plus b into 3n plus 1 plus half. Yn plus 2, a into 2 power n plus 2 plus b into 3 power n plus 2 plus half. Now see, this equation, this first equation, it can be expressed yn minus half is equal with a into 2 power n plus b into 3 power n. Likewise we can write yn plus 1 half, a 2 power n plus 1, b 3 power n plus 1 from this one yn plus 2 half a into 2 power n plus 2 b into 3 power n plus 2. Now from this setup you can write this determinant yn minus half yn plus 1 minus half yn plus 2 minus half, and here 2 power n plus 1 2 power n plus 2 3 power n plus 1 3 power n plus 2 equal with 0. Now for simplification what you can do, see from this second and third, from these two column what you can take 2 power n and 3 power n common respectively. Okay, so in that case what you have 2 power n 3 power n, then yn minus half yn plus 1 minus half yn plus 2 minus half. Here you have 1 2, here you have 2 square, that is 4. Similarly 1 3 and 9 equal with 0. Now these two terms cancel in the next step. Ultimately you need to find or simplify this determinant only. Okay, so this is how we can solve. All right, now take another problem of formulation part. So form difference equation with solution satisfying the following relation or expression. Okay, so that is given by log 1 plus z by 1 minus z y0 y1 z plus y2 z square yn z power n plus so on. Okay, see, so this type of question also important, that is the solution it satisfy this relation. So from here we need to determine. So what you can write, log 1 plus z, it can be expressed like this, 1 minus z multiplied with y0 y1 z y2 z square yn z power n plus so on. Now log 1 plus z, we have that formula z minus z square by 2 plus z cube by 3 minus z power 4 by 4 and so on. And from here if you just consider this multiplied form and just write it properly, y0, then the coefficient, see this one multiplied with this one we have y0. Now this one multiplied with the second term we have z, and here this one multiplied with the first term we have z. So what we can write, y1 minus y0 z. Similarly y2 minus y1 z square, just see this one multiplied with the first term you will have y2 z square. Similarly this one multiplied with this second term you will have another z square. So we have like this, and similarly if you can proceed further, ultimately we can do the comparison from both sides, okay, the coefficients. So if you compare both sides, see this term should be equal with the coefficient of z. Here the coefficient of z is 1, so you can write y1 minus y0, that is 1, then y2 minus y1, that is minus half, y3 minus y2, that is 1 by 3, and so on. If you proceed further, ultimately you have yn plus 1 minus yn, that is going to be minus 1 power n pi n plus 1. Okay, so see this is the difference equation we have. So in this equation if you put n equals to 0, you are going to get the first term, this one. If you put n equals to 1, you are going to get the second term, second equation actually. Likewise, so this is our final answer, that is this is our difference equation. Okay, I think it is clear. So this is how we can construct our difference equation. See, when we consider about difference equation, basically we have linear and non-linear. These are the two basic type. Another is homogeneous and non-homogeneous. So for the time being, we'll be restricting ourselves to linear difference equation and homogeneous non-homogeneous type. Okay, so one of the simplest model I can write for you, that is yn plus 1, that is equal with an yn plus cn. This is one of the simplest model of difference equation. Here obviously you can see the order, it is the first order equation. Okay, so an and cn, these are sequence. Okay, these are sequences, and that means they are nothing but function of n. Okay, now if cn it is 0, so we have homogeneous case, and if cn is not equal to 0, then we have non-homogeneous. Okay, you can identify it from here. Okay, this an and cn, they are function of n, again I am telling, but for the time being we can consider one of the simplest case by taking a and c as constant terms. Okay, so for the time being we can take a and c, an and cn as constant term. That means a and c we can take. So we have yn plus 1 equal with a yn plus c. We can write like this. Now corresponding to this, the homogeneous form is yn plus 1, it is a yn. This can be our first equation, that is the homogeneous equation. Now how to solve this type of equation? We have two techniques. That is, first it is iterative method. Another method, it is the first method, it is apply iterative technique. Another method is write like this, yn plus 1 minus a yn equals to 0. Okay, this one, and this equation it can be expressed as e minus a yn equals to 0. There is one relation between yn plus r, that is equivalent of writing e power r yn. This is one important relation with e and yn. Okay, n plus r, that is equivalent of writing e power r yn. Okay, so using this formula we can write like this, and after that we can proceed like cf and pi, because it is homogeneous. So pi part it is 0, particular integral it is 0, cf part there will be some value. Okay, this is one method. This is one method by finding cf, and pi, and another method, it is the iterative method. So first let me give you the idea regarding iterative method. So what is this iterative method? So for that, first thing, yn plus 1 is equal with yn, a yn. So first put n equals to 0 and see what you are getting. y1, that is a y0. Put n equals to 1, y2, a y1, that is a y0, that is a square y0. n equals to 2, y3, that is a y2, a y2 means a square y0. From the previous step we are writing a cube y0, and so on. If you proceed further, so what you are getting, yn, that is as per this setup you should get this one. Okay, so this is our general, this is our solution. Okay, this is our solution. Okay, where a power n, it will be there in the question, y0 it will be given in the question, so immediately we can find the value. That means the solution. Okay, so let's take one problem. Solve first question. Solve yn plus 1 equal with minus yn, y0 it is 3. Okay, solve this question. See the solution. You can apply the iterative method. That means yn is going to be a power n y0. Okay, here from this question itself, a value it is minus 1 and y0 it is 3. So you can put this value, that is minus 1 power n, y0 value it is 3. So yn it is going to be minus 1 power n into 3. This is our solution. Directly you can apply the formula. Okay, this formula, this one you can memorize. Okay, so this is iterative method. Now if we consider non-homogeneous equation, first let us discuss about this iterative method. Okay, later on we'll see this CF and PI finding technique as well. So if we take non-homogeneous equation, so for non-homogeneous, that is yn plus 1, it is ayn plus c. If we have this equation, so if we apply the iterative method, that is for n equals to 0, that is for n equals to 0 we have y1 a y0 plus c. For n equals to 1 y2 a y1 plus c. Now a y1 means a y0 plus c, that is a square y0 plus ac, plus obviously there is one c, this c plus c. Similarly y3 it should be a cube y0 a square c plus ac plus c. Likewise if you continue, what you have yn, it is a power n y0 a power n minus 1 c plus a power n minus 2 c, so on, ac plus c. Okay, now a power n y0 plus, if you are taking this c common, what you have, 1 plus a plus a square plus so on, a power n minus 1. How many terms you have here? A power 0, so n minus 1 minus 0 plus 1, so n number of terms you have here. So it is a geometric series with common ratio a. So you can write the formula, that is a power n minus 1 by a minus 1. By n it is going to be this one, provided a not equals to 1. So this formula you can apply. Okay, so you can apply this formula, that is given by this one. Okay, so yn equals to a power n y0 plus c into a power n minus 1 by a minus 1, provided a not equals to 1. Now if a equals to 1, if a equals to 1, then the main equation it becomes yn plus 1, that is yn plus c, yn plus c. So if you proceed further with this, so in that case yn, the solution, it becomes a value it is 1, so you can add y0 plus n into c. Okay, so that is for a equals to 1. So you can remember this formula as well. Okay, so if we have non-homogeneous equation, so in that case we can apply directly these two formulas. Now we can take one question. Solve yn plus 1 minus yn plus 4 with y0 as 3. Okay, we can try this question. See here, a value it is minus 1 and c value it is 4. So what is that formula? But we have yn equals to, just go back to that formula, a power n y0. So a means minus 1 power n y0 means 3 plus c value it is 4. Okay, c value it is 4. So here a power n, a means minus 1 power n minus 1 by minus 1 minus 1. So you can simplify 3 minus 2 times, here we have minus 1 power n minus 1. So what we have, minus 1 power n into 3, here minus 1 power n into 2 plus 2. So you can simplify minus 1 power n plus 2. This is going to be yn. Okay, quite straightforward. If you know that formula, easily you can solve. Now for the time being, what we considered this type of equation, see, this type of equation, that homogeneous or non-homogeneous case. Now if we have sequence, okay, instead of A and C we have AN and CN, so in that case we have one formula. We will state that formula or theorem. Let AN and CN be real sequence. Obviously n belongs to natural number set union 0, singleton 0, means n starts from 0, 1, 2, 3 and so on. Okay, AN and CN be to real sequence, then the difference equation, that is yn plus 1 AN yn plus CN, this is the first order, general first order linear difference equation with initial condition as y0, has the solution what is the form? See, yn, that is given by product of all the ak's with k from 0 to n minus 1 y0, plus here comes the summation with the product aj with j from k plus 1 to n minus 1 and k varies from 0 to n minus 1 c k, and the solution, this one is unique. This is unique solution. Okay, so here you need to remember this formula. This yn equals to product of all the ak's with k from 0 to n minus 1 and y0, and summation k from 0 to n minus 1 product of all the aj's ck. Okay, so here we have this one. Now we can take one question, that is solve yn plus 1, that is 2yn to n with y0 equals to 5. This one, see the solution. So here an, that is 2, and cn, it is n. Okay, and y0 it is 5. So what we can have, yn equals to product of all the ak's. Okay, so basically but we have 2 product of all the ak, k from 0 to n minus 1 into y0 value it is 5, plus summation product of all the aj's, okay, that is 2 here from j k plus 1 to n minus 1 ck, what is that? We have k, cn value is n, so k from 0 to n minus 1. Here instead of this quantity ak you can write 2. Okay, so for the first part, how many elements you have? N minus 1 minus 0 plus 1, so that is n number of elements you have, n number of 2's you have. Similarly, if from here how many 2's you have? N minus 1 minus k plus 1 plus 1, so basically n minus k minus 1 number of 2's you have here. So what you can write from here, yn equals to 2 power n into 5 plus summation k equals to 0 to n minus 1. Here you have 2 power n minus k minus 1 into k. See, this is our solution. Okay, this is our solution. Fine. So basically you need to remember this formula and identify what is an value, what is cn value, substitute in the formula, immediately you will get the answer.